Okay, guys, so we're going to finish section 6.1, and the last part of this section is dedicated to talking about rational numbers. Now, this is probably a relatively challenging part of the section, so don't be afraid to ask questions. It's going to be one of those things you're going to need to kind of talk to me about to get through. So, rational numbers are a number that can be written as a fraction. So we define them to be numbers that can be written as a fraction. Now, I believe previously we've mentioned rational numbers. And when we mentioned them before, we actually mentioned that it included the integers, that it included finite decimals, and repeating decimals. So real quick, before we define all of those, when we previously talked about it, I believe what we had done was we had talked about how they were the counting numbers, and I'm going to use the number symbol, counting numbers, as like the smallest group of numbers we had. Those would be numbers 1, 2, 3, 4, 5, and it keeps going forever. And then was the whole numbers, which included 0, 0, 1, 2, 3, 4, 5. Then we had the integers. The integers are positive and negative whole numbers. And then we have the rational numbers. And as I said, it includes integers, finite decimals, repeating decimals. Then there's a totally separate group of numbers called irrational numbers. And I believe we've talked about this before, but I'm going to recap it since I'm not certain. Irrational numbers are numbers that go on forever but never repeat. Wow, go on forever but never repeat. An example is pi. Pi is an irrational number because we know that it's like 3.1416, and then it just keeps going and it never repeats its pattern and it never ends. So pi is an example of an irrational number. Okay, and then I'm going to zoom out a little. The biggest group of all, the group of numbers that contain all of these numbers, both the rational and irrational, are the real numbers. So the real numbers are basically everything that we work with. Okay, but I'm going to come back and we're going to focus in on rational numbers. And I'm editing the definition a little bit because we want to actually say that rational numbers are numbers that can be written as a fraction. So reviewing integers, integers are positive and negative whole numbers. That means they are the numbers that go ... -3, -2, -1, 0, 1, 2, 3, and so forth. ... So those are the integers. Sorry, let me zoom back in a little bit here. Those are the integers. And all of those numbers can be written as a fraction, right? Because we can always take any whole number and put it over 1. So -3 over 1, -2 over 1, right? All of them over 1, they all can be written as fractions. Now, a finite decimal can also be written as a fraction, and that's something we're going to spend some time going over. And repeating decimals can also be rewritten as a fraction. So let me give you an example of a finite decimal. So a finite decimal is a decimal that has an end, okay? They also call them terminating decimals. So an example of a finite decimal, one that we're all pretty familiar with, would be like 0.5. And we happen to know that 0.5 is 1/2. Didn't look like a 5, sorry, there we go, is 1/2. So there you go, 0.5, that's a finite decimal, and it can be written as a fraction. Now, there are repeating decimals that also can be written as fractions. Actually, all repeating decimals can be rewritten as fractions. And we're going to talk about that too. So let me give you an example of a famous repeating decimal, 0.3 repeating. 0.3 repeating actually happens to be the fraction 1/3. And you might have known that, and you may not have, okay? But we can take any repeating decimal and write it as a fraction, and there's a process that we'll take for that. Okay, so let's go ahead and tackle this, the rational numbers here. So we're going to look at how to write a decimal as a fraction. So that's where we're going to start. Oops. And we kind of touched on this when we did place value in the previous section. So for instance, the number 0. Let's do 25, 0.25. And we probably know what fraction that is. Oops. But we base it on the place value. And because 5 is in the hundredths place, that means we're thinking 1/100, okay? That means that we can write this as 25/100. Now, 25/100 as a fraction reduces. We could divide top and bottom by 25 because 100 is divisible by 25. So that becomes 1, and 100 divided by 25 is 4. So 1/4. And like I said, you may have known that 0.25 is 1/4. So we can do that with any decimal that ends. Let me show you another one. Let's do 0.018. Okay. So the 8 is in the thousandths place, which means we can write it as 18/1000. And then we could divide at least by 2. So let's start with 2. So reducing that fraction will give us 9/500. Now 9 is divisible by 3, but 500 isn't divisible by 3. So there you go. That's it. Okay, let's try another more exciting one. Let's try, how about .002 4. So this is in the 10,000ths place. Just throwing on more. And here, even I'll make it exciting. Change this first 0. Let's actually make it 1 point. 1.0024. So as a fraction, then that would be 1 and 24/10,000. So I'm going to try to reduce the 24/10,000. I should be able to divide at least by 4. Let's start with that. So that'll give me 6/2500. Okay, so actually we can divide by 2 again. So we could have divided by 8. All right, so that gives me 3. So 1 and 3/1250. And there we go. 3 doesn't go into that. Okay, so that's how we convert decimal to fraction. Now to go the reverse direction, fraction to decimal. And we have talked about this. You would actually divide the fraction. So like, let's start with 3/4. We'll start with an easy one. Okay, so to convert 3/4 into a decimal, you would divide 4 into 3. But 4 doesn't go into 3. Okay, maybe we haven't talked about this, sorry. So to do the division, then we have to add a decimal and a 0. And I'm going to carry this decimal up. And I'm going to keep adding zeros until I either see a repeating pattern or it stops. Okay. So let's see. 4 goes into 30. Wow, my brain shut off there. 7 times, which will be 28. And then let's see, I'll have to borrow. So that's going to be 2, 10. So that's 2. All right. And then I'm going to add another 0 and bring that down. So 4 into 20, that goes in 5 times. And there you go. So 0.75. I like to put the 0 in front, but it doesn't really matter. There is how we would write that fraction as a decimal. Okay, let's try a more exciting one. Let's try 7/20. I encourage you, by the way, to pause the video and like try it yourself and see, okay, like kind of how we do it in class, just to give yourself a chance to practice it. Sometimes passively listening, you don't always get what you get from class. So that's kind of a way to help you get the same thing. So pause the video, maybe give it a try yourself and then see how I do it and see if you did it correctly. Okay, so I'm going to divide 20 into 7 and I'm going to add a decimal and a 0. So 20 into 70, that's going to go 3 times. And that'll give me 60. And then that'll give me 10. I'm going to add another 0. So 20 into 100 actually goes in 5 times. And there we go. So 0.35. Perfect. All right. Let's try 1/8. So decimal and a 0. So that's going to go in once with a remainder of 2. Add another 0. So 8 into 20 is going to be 2 times, which is 16. And then that's going to give me 4. Add a 0. Okay, there we go. So 48. That's going to be 5. So 0.125 is our decimal. Okay, kind of boring once you get the hang of it. Let's try a more exciting one. Let's try 5/6. So 6 into 5. Add a decimal and a 0. Okay, so 6 into 50. Oops, my decimal up. Okay, so that'll go in 8 times, which is 48. That'll give me 2. 6 into 20 would be 3 times, which is 18. And that'll give me 2. And if I keep doing this, I'm just going to keep repeating now. Every time I'm going to keep getting 3. So there we go. I have a repeating decimal. I'm just going to keep getting 2. And that means it's going to go in 3 times. So I'm going to write this as 0.83 repeating. So I'm just going to put the bar only over the 3 because that's the only part that's repeating. All right. They call that the part that repeats, by the way, the repetend. I'm going to write that down. The repetend. That is the repeating part. So that's the part that's under the bar when we write our little bar to indicate a repeating decimal. Okay, so let's just try one more. Make sure we feel good about it. Let's do, trying to not torture ourselves here. Let's try 3/11. All right. So 3/11. 11 is going to go into 3. but then we'll treat it as 30, adding the decimal and the 0. So 11 goes into 30 2 times, which is 22, and that's going to give me 8. Add another 0. Okay, so then that's going to be yeah, I did that right. Sorry, my brain shut off there. Okay, so 11 can go, wait, 222. Hold on, sorry. It shouldn't go in evenly because right now it would go in evenly. What am I doing wrong? It goes in 2 times. Wow, I'm just going to grab my calculator because I'm really struggling here. That's a shame, isn't it? Yeah. Oh, this should be a 0, not an 8. Wow. Sorry, guys. I'm clearly tired. There we go. 11 into 80. Whew, got so confused there. Okay, so 11 goes into 80 7 times, which will be 77. And when I subtract, that'll give me 3 and a 0, which is 30. So 11 goes into, okay, actually, here we go. It's going to start repeating now because that's the first number we had, right? We had 30 to begin with. So that's going to go in 2 times, which will be 22. And then that's going to give me 8, which is going to be 80. So it's going to just start repeating 27, 27 over and over again. So I'm going to put the bar over 27 because that's the part that's repeating. There we go. All right. Lovely. So now here's our next phase. So going from decimal to fraction, not too hard, okay? When it's a finite decimal, and fraction to decimal is definitely not that bad. But to go from a repeating decimal to a fraction, that takes a little bit of work. Repeating decimal to fraction. All right. So let me give you an example. I'm going to obviously do a few examples, but we'll step through them pretty slowly. Here's the idea. It's kind of a very specific process. There is more than one way to do this, but this process kind of builds on stuff that we've talked about previously. All right. So let's say I want to change 0.37 repeating into a fraction. Okay. So here's the idea. I'm going to create an equation out of this. So I'm going to set it equal to n, where n is going to be my magical fraction that I'm trying to find. Okay. So whatever n comes out to be, that is my magic fraction. I'm trying to figure out what fraction I can create that's going to be 0.37. All right. So here's how you do it. I'm going to actually, rather than write 0.37 with a bar, I'm going to write 0.37, 37, and it just keeps repeating, right? Forever and ever. So dot, dot, dot. I'm just going to, so 3737, and there we go. And it keeps going. The reason I'm doing that is I'm now going to multiply both sides by 100. So here's what happens on the left side. On the left side, I just get 100n. But on the right side, when you multiply a decimal by 100, it moves the decimal twice. So this becomes 37.3737, repeating forever and ever and ever. All right. Now, I know that seems like, why would I do that? But here's why. I want to get rid of the decimal. The decimal is causing me a problem. I want to be working with whole numbers so that I can get a fraction. So here's how I'm going to get rid, quote unquote, of the decimal. I'm going to subtract my original statement, n, from this expression. So I'm going to subtract, let me write it like this, n equaling 0.37 repeating from this. And what's going to happen is the left side of the equation, when I subtract 100n minus n, that just becomes 99n. And on the right side, since both of them have this decimal that's repeating on forever and ever, That cancels out. And I'm left with just 37. And now I'm going to solve for n. So I'm going to divide both sides by 99 to get n by itself. And this is the fraction answer, 37 over 99. Grab your calculator, divide it, and it is going to be 37 repeating. All right. So here is the process. This is the quote unquote trick. This multiplying by a specific number. So the goal of this number is so that we get the part that's repeating in front of the decimal. And then all the extra repeats are going to just go after the decimal. Let me give you an example. Let's say, let me do another one. Oops. Let's say I want to do 0.612 repeating. I'm kind of making this up. All right, so here's what I'm going to do. I'm going to make an equation and say that there is some magic decimal that equals this repeating decimal, 612, 612, 612 forever and ever. Okay, it keeps going forever and ever, dot, dot, dot. All right, so now I want to move the decimal so that I get one set of repetition in front. So I want to get one of those 612s in front of the decimal. So I'm going to multiply by 1,000 in order to move it 3 places. So on the left side, I have 1,000n. And on the right side, I have 612.612, 612, 612 going on forever and ever. And now I'm going to subtract my n statement. And here I'm going to line it up, dot, dot, dot. My repeating 612 that goes on forever. So on the left side, I'm going to get 999n. And on the right side, I'm going to get 612. So dividing by 999, I have n equals 612 over 999. Now, this might reduce. In particular, I'm thinking 3 is going to go into all of these numbers. So I'm going to try reducing this really quick. So 612 divided by 3 comes out to 204. And then 999 divided by 3 is 333. And I think that's divisible by 3 again. It is. So that comes out to 68 over 111. And you can use my tricks that I showed you for checking to see if the fraction is reduced. Remember, your calculators can reduce your fractions for you, so you can make sure your fraction is reduced, okay? But you do need to show me the work on how you reduce your fraction. I mean, I don't mind you using your calculator to check, but you do have to show me these steps of reducing. And there we go, 68 over 111. If you take 68 over 111 and divide it on your calculator, you're going to end up with 0.612 repeating. All right. Okay, so let's try another one. Just kind of practice a few times to make sure we understand this process. So let's say this time we have 0.572, but the repeating part is the 72, not the 5. So I'm going to start by doing n equals 5.72. Oops, sorry. Such a dork. 0.57272, and that 72 just keeps repeating forever. Okay. First step. Sorry, my brain shut off there. This one's a little different because of this extra 5. The fact that there's this kind of extra piece, this actually takes an extra step. Okay, here's the extra step. First thing I'm going to do is put the part that isn't repeating in front of the decimal. So to do that, to move the decimal once, I need to multiply by 10. So that gives me 10n equals 5.7272, repeating forever. Now I'm going to do what I did earlier, and I'm going to move the decimal after the first repeating set. So I'm going to move this decimal after the first 72. So to do that, I'm going to multiply by another 100. So on the left side now, I actually have 1,000 because 10 times 100 is 1,000. And on the right side, I have 572.72 repeating. So instead of using this first number I started with, I'm going to use this number, the number I used after I adjusted for the non-repeating part. So this is the number I'm going to subtract down here. So I'm going to subtract 10n and 5.72 repeating from both sides. So on the left side, I'm going to get 990n. And on the right side, the 0.72 repeating part, the repeating part of the decimal goes away. And I'm left with 572 minus 5, which is 567. And now dividing by 990, there is n. Okay, so let's try another one like that. Let's try 1.067 repeating. So now we even have a 1 in the front. That's not going to be too big of a deal. So I'm going to set it equal to n. 1.06767. So the 67 is repeating. So first thing I need to do is get rid of the part that isn't repeating at all. So I need to multiply by 10. And that's going to give me 10n equals 10.6767 repeating. So now I got the repeating part going all by itself on the right. And this is the piece I'm going to use when I do the subtraction. But I'm not done. Now I need to bring one of the repetitions up to the front. So I need to move the decimal right here. So I need to multiply by 100 to do that. 2 decimal places, 2 zeros. So that's going to give me 1,000n equals 1067.67 repeating. 67 is repeating forever. Now I'm going to subtract 10n equals 10.67 repeating from both sides. So this is the thing I'm subtracting. The adjusted one, the one that gets rid of the non-repetition part, that 0 right there, and moves it first. Okay, so let's see. Oops, sorry, my phone's ringing. Let me get rid of that. I apologize. Okay, so that's going to give me 990n equals, get my calculator. So this is, so first of all, this goes away. Oh, actually, that's not too hard to do in my head. That's going to be 1057. All right, dividing both sides by 990. And there's my fraction. Now let's see if it's reduced. So I'm going to use the calculator trick. I'm going to put it in my calculator and use the frac button and see if it reduces any further. And for me, it does not look like it does. So I think that's it. That should be the answer. It's an improper fraction. Which is fine. There's nothing wrong with that. You could write it as a proper fraction if you wanted, but this is fine. This is a perfectly reasonable answer.